daily lessons, page 139. It is a good thing I like you guys because, man, there's a lot of stuff to do all at once. Anyway, page 139. No calculator permitted, so get excited, you get to do this one without a calculator. And what you're going to do is you're actually going to try these ones. So I'm going to walk you through this, but here's where I'm going to stop you and trust you that you're going to stop the camera, or stop the video and try these ones. So try them first, and then come to the parts where you think, okay, I actually really need some help on that. So stop this now if, you want to be honest and awesome, which you are. Okay, now you're back. So maybe you need help somewhere on this. You can fast forward it to the part that you need help on. If you're finding the average velocity, as soon as you see average, you should be thinking slope of the secant. Average velocity is, you have to go to the graph above that. Think about, well, what is velocity the derivative of? The derivative of position. So to find average velocity, you're going to want to find the position, or use the position function and find the slope of the secant. So you're going to want to find p of 2 minus p of 1 over 2 minus 1. Hopefully you already did this, and when you put this in, you should get negative 8. The position function was given in feet, so position minus position, you have feet. 2 minus 1, that was measured in seconds, so you should have gotten negative 8 feet per second for the first one. Okay, the second one, in part B, it says moving to the left. What I'm going to do is I'm going to write what I know about this first. A particle is moving to the left, so the particle is moving left when, hopefully you got this by now, the velocity is less than 0. So a particle moving left when the velocity is less than 0. So what I need to do is I need to figure out, well, when is the velocity less than 0? When is it equal to 0? So you're going to take the derivative, p prime, because that's the same thing as velocity. And if you take the derivative, you get 3t squared minus 8t minus 30. You set this equal to 0. And when you do that, you can factor this into t minus 30 times quantity 3t plus 1, which you know because you already did this. T is equal to 3. T is equal to, this would be equal to negative 1/3. T really looks like plus there, but yours probably doesn't. I can see for part B, it's talking about on what intervals is a particle moving to the left, but up here it says when time is greater than or equal to 0, so I don't have to worry about this one. The only time the particle is changing directions is at t is equal to 3. So I'm going to make a chart. I've got t, and I'm starting at 0, I'm stopping at 3. 3, I know it's 0, and I'm going for forever, because it says just t is greater than or equal to 0. So 3 to infinity. And I'm seeing what is happening to v of t, also known as p prime. So I'm going to put in a value from 0 to 3 into here. If I put in, let's say 1, this value would be negative, this would be positive, negative times positive is negative. 3 to infinity, this value is going to be positive, so let's say I put in 100. 100 minus 3 is positive, positive. That means my particle is moving left from 0 to 3, and right from 3 to infinity. A particle is moving left when v of t is less than 0. Therefore, particle is moving left. You could say on the interval from 0 to 3, but make sure that you have units. So that's measured in seconds. From 0 to 3 seconds. Okay, and this one, find the value of p prime of 3 and p double prime of 3. So, based on these values, describe the particle, or the motion of the particle. Think about what these things mean. So p prime, p double prime. I can figure those ones out. If you do that, you should get but you should have done that already. If you didn't take the time to stop it now, make sure you get this. That p prime 3 is equal to 0 feet per second. Notice I'm putting units on this. P double prime of 3. You take the second derivative, which is, by the way, p prime double prime of t, it would be 6t minus 8. You get 10 feet per second. But what this is asking is what's going on with the particle itself. So I need to think about, well, what is p prime? What is p double prime? The derivative of position is velocity. The second derivative, or p double prime, would be v prime of 3, which is acceleration. So things that you need to say in this one, I'm running out of room, so I'm not going to do it, but things that you should have in part C. You should have that this particle's velocity at 3 is 0 feet per second. The acceleration is 10 feet per second, which seems really weird. Remember that you can stop though for an instant, the particle cannot be moving, but have an acceleration. There's nothing I can say about speed because the speed of the particle is only when they have the same signs or opposite signs. This one's 0, doesn't have a sign. So what you should be saying, the velocity at time t equals 3 seconds is 0 feet per second. The acceleration at time t equals 3 seconds is 10 feet per second. That's all the info you need on that one. Okay, maximum velocity. This is a really good question. Maximum velocity, think about extreme value down. Maximum, absolute max. This can happen at endpoints or when the derivative is equal to 0. So what you need to check is I'm going to write up here because I'm running out of room. You need to check the position at 1. You need to check the position at 3, which, by the way, I think I've already done. Actually, what was I thinking? You don't need to do this. It's maximum velocity. So, you need to check not position at 1 and position at 3. You need to check what is the velocity at 1, what is the velocity at 3, silly me, and any place where the derivative of velocity is equal to 0, because that would be the relative min and relative maxes. So v of 1, if I try that, do I know this one? Hopefully you're doing this along with me as I figure this one out. From t equals 1 second. Guys, that's super weird. Do you see this one? Mine says t equals 1 second, and yours should say t equals 0 seconds if we're on the same one. So I have a little note by this, but that's why it looks weird. So on yours, this probably says t equals 0, and that's why I'm off, because my answer is following yours. I don't know. So change that on your notes itself. That should be t equals 0 to t equals 3. So I'm going to find v of 0, v of 3. Those are my endpoints, and also wherever the derivative is equal to 0, the derivative of velocity. So v of 0 is -3. Find the derivative, and put in 0. V of 3 you should have gotten 0. By the way, feet per second. Feet per second. But you will also want to find where is the derivative equal to 0. So in part D, you need to find where is v prime of t equal to 0. This happens at t is equal to, I believe it's 4/3. Because that's a potential min or max. So I need to check v of 4/3. V of 4/3 is the same thing as 16/3 minus 32/3 minus 3. And the reason why I stopped here, 16/3 minus 32/3 minus 3. That's not simplified at all. But right now, I showed enough of my work to show that this value is going to be negative, and it's going to be lower than this. So this one seems really weird because the maximum velocity is going to happen at t equals 3 seconds. because the velocity is 0 at that time. So v of 0, the maximum velocity is 0 feet per second. So on this one, you should be saying v of 0 is equal to 0 feet per, or I'm sorry, v of 3 is equal to 0 feet per second. I think I might have just confused that. At time t equals 3, the velocity is going to be the greatest as v of 3 is greater than v of 0 and is greater than v of 4/3. And show all your analysis there. Again, I ran out of room. You didn't, but you know, I'm making a video to help you out, so you know, do with it what you need. Okay, I'll actually erase some of this stuff because total distance is pretty important. But total distance, not that the other parts aren't, they are. Okay, total distance you should be thinking about from 1 to 5. So, if it was net distance, it would be easy because I could say p of 5 minus p of 1 and be done with it. Find the absolute value. Total distance, not so much. I need to figure out when it's moving left, when it's moving right. In part B, we already figured out when this particle is moving to the left and when it's moving right. We said in part B that, I just erased it, but at time t equals 3. That's when the particle changes directions. So that's what I need to look at. So I need to find the initial position, p of 3 minus p of 1. Because at 3, I know from part B, if you go back to your work that I just erased, this is going to be where the particle changes directions. So I have p of 3 minus p of 1, find that distance. Plus, final position minus the p of 3 then. So I've got p of 5 minus p of 3. You need to find the absolute value of both. When you do this, you should find that p of 3 minus p of 1, try this on your own. Stop me, try it, make sure that you can get this, that this distance is the absolute value of negative 12, so you get 12. Over here, you should get p of 5 minus p of 3 is the absolute value of 28, which is 28. If you just say p of 3 minus p of 1 and add it to this, it will give you the net distance, not the total distance, and you'll be very sad. But 12 plus 28, you get 40. You're talking about distance. Make sure to include units, feet. Show or explain your analysis. You would say something along these lines. So if I were to, but you can see by the time it's starting to get late and I want to go home, p of 3 minus p of 1, you would say this is when a particle is moving to the left. And you can see that from your part B analysis. This is when a particle is moving right. I add the distances when the particle is moving left and moving right. Something along those lines. So this is a pretty long problem, but you know, you're pretty smart and you persevere. Yeah, next one.